In this video, we're going to look at a couple of examples using our linear equations of motion. So that's when we're trying to calculate quantities like time, distance, velocity, or acceleration in a system in which the object's moving in a straight line. So here we have a problem where a car is traveling in a straight line at 25 meters per second. The car brakes for 5 seconds and the speed is reduced uniformly to 15 meters per second. How far does the car travel in this time? Let's take a bit of a think about this. In a problem like this, one of the first things to do is to identify what it is that we're looking to find out. And what we're looking to find out in this question is how far it travels. This is our distance, and this what we call S in our equation. So S, that's our unknown here. We're told the car is traveling 25 meters per second at the start. So our initial velocity is 25 meters per second. So ms to the -1 is the same thing as m/s to represent meters per second. And our final velocity at the end of this time is 15 meters per second. And we're given a time of 5 seconds. So we have 3 pieces of information and we're asked to find one thing. We're told the speed is reduced uniformly, which means it's constant deceleration, which will always be the case in this. Of course, we'll all have constant deceleration or constant acceleration. We're not going to have that vary in our questions, but it's useful to know that to make sure this is definitely a scenario in which our equations apply. Now, we have to use the correct equation of motion in order to calculate this value. And if you remember from the class, we have 2 different equations we can use in these circumstances. We have our equation for S equals ut plus a half at squared, and we have S is equal to u plus v, that's a bigger bracket I wanted, u plus v over 2 times t. So which one to use? Well, some of you will see this at a glance, but in this first equation we know u, we know t, we don't know a, no t. In our second equation, we have u, v, and t, so we have all the values we need in order to work out the value for s. So we can erase this, I'll erase these ticks as well, and we can apply this equation directly. So I'll bring this over to the center of our screen. So we can use this equation for distance, and all of our units are correct. They're all in meters per second or second. So we can put them directly in to say S is equal to, in our bracket, we've got 25, that was u, plus 15 divided by 2, times our time, which was 5. So we've got 40 divided by 2, I'll put it all in, 40 divided by 2 times 5, which is equal to 100. And remember, our unit is distance, working in meters. 100 meters is our answer for this first example. That's using one of our equations of motion. Let's have a look at another problem now. So I'll move to a new bit of whiteboard here. Move down. Let's look at our second question. So sticking with a vehicle theme. In fact, we've got 3 choices for this one, so we get a bit of guidance, but we'll still do all the working. A motorbike undergoes constant acceleration from rest. That means it starts off with a speed of 0 and travels a distance of 60 meters in 6 seconds. What is the acceleration of the motorbike? So let's start off by writing what we're looking for. We want to find the acceleration. That's our unknown here. It starts from rest, so u, our initial velocity, is 0 meters per second. We are told it travels a distance of 60 meters, and that happens in a time of 6 seconds. So we're looking for A, and we don't have V. So which of our equations can we use to solve this problem? And really the short answer to this is we look for the one of our 4 equations that doesn't have a V in it. And in this case, the equation we're looking for is S equals ut plus a half at squared. So although it's a we're looking for, this is the only equation we're given that has a, u, t, and s in it. But that's not a problem. We can put our values in and rearrange it. And you can rearrange it to get a as a subject first, or we can just put our numbers in. And I think putting our numbers in sometimes is the easier route to go down. So we're going to try that here. So for s, we have 60 is equal to u 0 times 6, that's going to be 0, plus a half times a, which we don't know, times 6 squared. So we can simplify this a little bit first though. So we get 60 is equal to, that's gone, that's a 0. A half times a times 6 squared. 6 squared is 36. Half of 36 is 18. So 60 is equal to 18a. So a will equal 60 divided by 18. And that, once we work it out in our calculator, is equal to, with a bit of rounding, 3.3 meters per second squared. And in this question, being multiple choice, we know that what are the options. So yes, this is the answer to the question. So that's another example of how we use one of our equations of linear motion to solve a problem.